Hi everyone, welcome to this new video lecture on Introduction to Cloud Infrastructure, Chapter 2, Lecture 2. As a recap, in this video lecture, we will present the topics starting from historical evolution of data centers. Because in Chapter 2, Lecture 1, which is our previous video lecture, has already presented the foundation and essence or fundamentals of cloud infrastructure and concepts or topics related to core components, service models, deployment models, benefits and challenges have already covered in Chapter 1, Lecture 1. So, in this new video lecture, we will continue to present historical evolution of data centers, data center components, and the rest. So to begin with, section 2.1, historical evolution of data centers, for the academic or for the lecture purpose, we have categorized it into 4 different perspectives of evolution of era on data centers. What we mean by this evolution of era means that we will present or note the different advancements, technological advancements and gains, insights that have been witnessed through different evolution of era. The first one is that 1940s up to 60s, the data centers is mainly characterized by mainframe computers, and it is also known as the era of centralized computing. So what it means, the details will be presented in the coming slide. The second era of evolution on data centers is characterized by dedicated computer rooms, and it was noted as early networking. That means this era of evolution is at 1970s up to 80s. The third historical evolution era of data centers is that presented as 1990s up to 2000. This is obviously, it is characterized by internet revolution, the so-called internet boom. And the other key feature or advancement in this era evolution is that virtualization and redundancy measures. The last evolution or data centers evolution era is noted as 2010 up to present. That means the major advancement in this evolution era is this today's cloud computing, hyperscale data centers, and sustainability. So what means every area is described here. The mainframe computers, what we mean by in 1940 up to 60s, it is described as the era of centralized computing, meaning these mainframe computers were known for large room-sized computers that serve as the backbone of early computing. So a typical example for this, the IBM 701, one of the first mainframe systems used by businesses and governments since those early days. And the other feature is that it was the era of centralized computing, meaning all computing resources were housed in a single location. Users interacted with the system through punched cards or terminals. So these punched cards or terminals are devices that have no their own or an integrated processing power. Instead, they help us just to send inputs to the central servers. Example, banks and government agencies used mainframes to process financial transactions and census data on those early days. Then the second era evolution, which is known as the rise of dedicated computer rooms and early networking, that is noted as 1970s up to 1980s. So in this case, the major advancement or features was computer rooms, and organizations began setting up dedicated spaces to house computing infrastructure. Cooling and power management become essential due to increasing hardware density. So examples, universities and research institutions maintained computing centers for academic use. So what it means that in this case, it was an era of the rise of dedicated computer rooms and early networking. Early networking also described or shows the development of local area networks, the so-called LAN, allowed multiple computers to connect and share data. And then a typical example during this era evolution is that the ARPANET, precursor to the internet, was launched, allowing computers in different locations to communicate. In 1990s up to 20s, which is this era, evolution is known as the internet revolution and virtualization specifically, meaning that the internet expansion, the rapid growth of the internet, increased demand for robust data centers. Companies like Google, Amazon, Yahoo builds large-scale facilities to store and process data. This era of revolution is described as the internet boom. So the other key technology or feature is that the emergence of virtualization during this area. That means introduction of server virtualization enabled multiple virtual servers to run on a single machine, and improved resource utilization and reduced hardware costs have been possible. This we have mentioned already in the previous chapter 2, lecture 1, and even in chapter 1, what it means exactly, the idea behind the virtualization. So it is obviously it helps resource utilization and reduce hardware costs because it abstracts and transforms the physical hardware or computer resources into virtual entity. Therefore, the example for this virtual technology is that the VMware launched its first virtualization platform, transforming how businesses manage IT infrastructure. And the other key characteristics during this evolution is that the redundancy and disaster recovery, meaning data centers during those days implemented backup systems and failover mechanisms and geographically distributed infrastructure, meaning financial institutions set up backup data centers to ensure business continuity during system failures. So due to the emergence of redundancy and data disaster recovery, the availability of services were possible during this internet revolution and virtualization time. In 2010 up to present, which is the present day, cloud computing, hyperscale, and sustainability was the major advancements that we witnessed this day. So cloud computing, meaning that in this case, shift from on-premises data centers to cloud services provided by these various cloud service providers, the CSP, enabled businesses to scale resources on demand. Example, Netflix. This is a well-known company for video streaming, migrated its entire video streaming infrastructure to AWS to handle fluctuating user demands. So in this case, this Netflix will have ample time to focus on their innovation or business domains, just business strategy goals, instead of to worry about other network installation and other security and other issues related to cloud computing. That is what it means, that they just simply transfer their worry to the third party such as AWS, the cloud service provider. Hyperscale data centers is another major advancement in this generation or evolution. Massive facilities designed to support large-scale applications with millions of users. And then the typical example is this time, Facebook data center in Prineville, Oregon, handling billions of users' interactions daily. That's what we can witness. Sustainability and green computing is another feature of this generation or evolution. Focus on energy efficiency, renewable energy resources, carbon neutral operations or carbon free. Example, Google and Microsoft invest in AI-powered cooling systems to reduce power consumption in data centers. That is now what the era evolution of data centers, starting from the early days up to this green or carbon-free data center realization. So this section 2.2, which is about data center components. In this slide, we are about to classify the main data center components into three categories. The first one is IT equipment, and then facilities, and then the management tools. That means in IT equipment, we are mainly referring to the servers, storage, network devices, or networking devices. In the case of facilities, these are the main components that enables the data center infrastructure, such as power, cooling, and physical security. Physical security is also very important. And the other is that the associated management tools. Okay, the monitoring software and automation platforms are the data center components. Section 2.3, it is design considerations for data centers. That means what are the design elements that has to be considered in place for data center establishment. The first one is that the requirements, meaning capacity planning for growth and compliance with industry standards. There are different regulations and compliances set by organizations in line with the customer's satisfaction. The second one is power, which means primary and backup power sources are very, very important things to be considered in our design of data center services. And the other one is UPS systems for emergency backup. So the backup and the restoration, during the data loss or data disaster time. So in such scenario, we need to think in our design, or we need to consider what mechanisms do we have during emergency just for data backup and total system restoration. And the other thing is that efficiency. So efficiency is our concern, meaning that optimized cooling strategies such as hot or cold ISIL containment is very important. And the other thing is that monitoring power usage effectiveness, that is in short noted as PUE. We will see how this value is computed and its interpretation, what it means exactly. This is used as a metric to evaluate the power usage effectiveness in general for data centers and cloud infrastructures at large. So the redundancy is another consideration for data centers, meaning that failover systems and backup strategies. And disaster recovery planning. These are also the two important challenges that could happen, and there has to be a solution or a backup policy such that the redundancy is our consideration for data centers establishment. Section 2.4, that is a power calculation and PUE that I have said. So this power calculation, first, it focuses on assessing IT and facility load and factor in redundancy and scalability. Meaning this PUE is an efficiency metric, which I have said already, is described or equated as total power consumption divided by IT power consumption. Meaning this PUE is computed as the total power consumption or total facility consumption divided by the IT power consumption or the IT computing devices. That means lower PUE values indicates higher efficiency. Just the value of PUE, which is 1, is the ideal value. So let's see what it means, this ideal PUE means. We will see on the next slide in detail. So challenges related to this power calculation and PUE is that reliable power supply, obviously, cooling system inefficiencies, this is another challenge, compliance with environmental regulations, like the green data centers and other green technologies are very, very important to be considered in our design considerations of data centers. So the green technology is one requirement to avoid such challenges. So what it means is that the power usage effectiveness PUE, the total facility power divided by the IT equipment power. What it means is that this total facility power is, we have said already here, these facilities are that assess IT and facility load in general, whereas the IT power consumption are power consumption that spends to the competing services dedicatedly. So this is what it means. Interpreting PUE is very important in assessing the efficiency of power usage. That means a PUE of 1 represents an ideal scenario where all the power is used solely by IT equipment with no overhead. Meaning in practice, most data centers achieve PUE values between 1.2 and 2, meaning a lower PUE indicates higher efficiency, meaning less power is wasted on non-competing functionality. So this total facility power consists both competing and non-competing, whereas this is the competing power only. So the total facility divided to the total IT equipment or total power spent on competing is just a ratio between these two values, which gives PUE. So the lesser the value is the best. So benefits of monitoring of this one is very important. One, it helps us benchmarking and improvement, meaning regular tracking of PUE helps identify inefficiencies in cooling, power distribution, facility design, allowing for target improvements. And the other important or benefit is that cost reduction in sustainability. Improving PUE not only lowers operational costs by reducing energy waste, but also helps in meeting environmental sustainability goals. Comparative analysis also is possible to make based on the monitoring PUE, meaning that PUE provides a standardized method for comparing the energy efficiency of different data centers, aiding in decision making and best practices adoption. So coming to this PPT or this lesson is that challenges in cloud data centers are also to be noted. What is the challenge? The challenge is that cloud data centers are essential for modern computing but face several challenges. What are those challenges? Mostly they have an impact on this efficiency, cost, and sustainability. So power supply reliability, meaning that the continuity of power supply. There could be power outage at some point. So that means redundant systems complexity. Backup power increases infrastructure complexity and cost. Integration of renewable energy. Intermittent availability of renewable complicates stable power supply. And the other challenge is that cooling and terminal management, meaning heat dissipation. High density IT equipment generates excessive heat. So this is one challenge, and that affect our data center performance or computing performance. And the other is that innovative cooling solutions like liquid and cooling require careful implementation. The third one is scalability and load variability, meaning dynamic workloads, over provisioning versus efficiency, balancing extra capacity with cost-effective operation. So these are also the scalability and load variability is another challenges in data center. So complexity of management and monitoring, real-time analytics such as continuous monitoring to optimize power usage is another key challenge in data center design. Predictive maintenance, anticipating failures to enhance efficiency. That means the adoption of different technologies such as AI and ML in order to do the predictive maintenance is also another challenge. Environmental and regulatory pressures is also another challenge. That means sustainability goals, reduction carbon footprint and energy consumption, or the green technology is also achieving or realizing such things. Data centers is also challenging. Compliance and standards, meeting evolving environmental regulations. So in general, the takeaway of this whole presentation we have made is that cloud data centers face multiple challenges in power, cooling, scalability, management. Addressing those challenges require innovation and regulatory compliance. So this regulatory compliance, such as the principle or the compliance related to this energy and related or power usage, is a key challenge. So future advancements in energy efficiency and cooling technologies will remain critical. Section 2.5, which is about cloud management strategies. In this case, resource provisioning, auto-scaling, and elasticity for demand fluctuations. This is the cloud management strategies that need to give emphasis. And the other thing, that means resource provisioning, that means auto-scaling, elasticity for demand fluctuations. As we have as the cloud infrastructure is supposed to support the multi-tenant environment. So in such scenario, the resource provisioning must support auto-scaling and elasticity for demand fluctuations. So monitoring and performance is another management strategies that need to be in place. Real-time analytics, such as the predictive models, integration of predictive models into our management strategies is also a key point to be considered. System health checks and monitoring this, and the real-time performance is also another cloud management strategies that need to be taken seriously. And the other thing is the security and compliance, identity access management, in short known as IAM. That is another encryption. So this encryption concept is also known for achieving the security and compliance, but that has to be noted also in the cloud management strategies. What type of encryption to be used with the level of complexity that the user and the cloud computing services available in the cloud. And the other thing is that cost optimization, usage analysis, resource right sizing. That means whatever the cloud management strategies need to optimize or need to think of the trade-off between the available resources with to the customer with best fit or best cost or optimal value. So the other thing is that the resource provisioning, as I have said, for example, streaming services like Netflix automatically scales its continuing resources during peak hours to handle increased user traffic. When demand decreases, resources are deprovisioned to save costs. So this is a typical characteristics of cloud computing. And the other one is the monitoring and performance, such as the AWS cloud, which monitors CPU utilization, network latency, and then database performance. If an application server exceeds 80% of CPU usage, an alert is triggered and an additional instance is launched to balance the load. So these are nothing else, just they are simply, for example, the security and compliance. Then the Google Cloud Identity, this IAM, ensures that only authorized users can access specific resources. So these are just like use cases for this brief content is related to this section 2.5 cloud management strategies. So one can go in detail to understand every use cases associated with these 4 cloud management strategies. And the last section 2.5 is that the next section 2.5 cloud software deployment considerations. So the first one is that deployment strategies such as the continuous integration and continuous deployment CI/CD pipelines automate software delivery, rolling updates minimize downtime. So that means in the deployment strategy, rolling updates is minimizing or supposed to minimize downtime. And the other thing is that the containerization, which is Docker and Kubernetes, enable portability. We have already said these 2 technologies are very important as a package, as a containerization in case of cloud software deployment considerations. And the other is that the scalability, load balancing for distributed workloads. We exactly know what load balancer is doing. So load balancing is something that has to be in place for distributing workloads in case of the cloud software deployment considerations. So in case of software deployment considerations, one has to consider in our strategy the load balancing for distributing tasks based on certain algorithms such as the round robin and others. Security, secure coding practices, compliance verification is something that has to be considered in the cloud software deployment. So the details and use cases can be can be checked in this PPT. That means in the case of deployment strategy, what we mean by the CI/CD pipeline, continuous integration and continuous deployment, automates tests and deployment. For example, GitHub Actions can automate deployment to AWS after a developer pushes new code. Rolling updates means instead of updating all instances at once, rolling updates gradually replace old versions with new ones to prevent downtime. So Google Cloud Kubernetes, just noted as GKE, can perform rolling updates to ensure application availability. So the other thing is that the containerization, using lightweight portable containers to deploy applications consistently across environments. For example, Docker. Developers package applications into containers, making them environment independent. For example, Spotify uses Docker to run the same application code across different cloud environments. Kubernetes orchestrates and manages containerized applications. For instance, Airbnb uses Kubernetes to scale its back-end services dynamically. And the same is true for scalability. The load balancing ensures even distribution of traffic to prevent overload on a single server, meaning AWS Elastic Load Balancer, ELB, automatically routes requests to healthy instances, maintaining system performance. Horizontal scaling, meaning adding more instances to handle increasing demand, such as Netflix dynamically adding cloud servers during peak streaming hours. So these are use cases. Otherwise, we have said it this detail on this PPT. So these two PPTs are all about the use cases and demonstrations or examples being used to clarify the details associated with these four important concepts. So the last one is security, implementing security best practices to protect cloud applications from threats and ensure compliance. For example, secure coding practices. Developers follow security standards like OWASP top 10 to prevent vulnerabilities such as SQL injection. This is one attack. And compliance verification, meaning cloud services must comply with regulations like GDPR for data privacy and data disaster. For example, Microsoft Azure Security Center helps organizations meet compliance requirements by monitoring security risks. So, coming to these future trends in cloud infrastructure and data centers, these are mainly described by edge computing, AI automation, sustainability, security enhancement. What it means, edge computing, it's nothing else. It is reducing latency with localized processing, because this edge computing enables users to process their data and applications very closer to their source. That's why it's very possible to reduce the latency because of localized processing. And the second one feature that shapes or geared cloud infrastructure and data centers is that AI and automation. The integration of these two technologies is very important for predictive maintenance and resource optimization. And then sustainability, energy efficient designs such as the green technology is also important or expect to guide the future trends in cloud infrastructure and data centers. Security enhancement, AI-driven threat detection, advanced encryption and cryptography is also one or major feature that can guide our future trends in cloud infrastructure and data centers. So details on these points like edge computing, the autonomous vehicles, the smart factories are examples of edge computing. And the AI automation is that the Google AI powered data centers, the AWS auto scaling, web services automatically adjusts cloud resources based on demand, improving efficiency and cost savings. So this is what it means, that AI and automation. Sustainability, such as Microsoft carbon neutral data centers. This Microsoft aim for 100% renewable energy in its data centers by 2025 using wind, solar and hydroelectric power. Google sustainable AI. These are also the Google's AI models analyze energy usage and suggest optimization to minimize environmental impact. So nowadays, these cloud service providers have taken already initiative to provide data centers and whatever cloud infrastructure services in general, the cloud computing, based on the carbon-free or based on the green technology, such as the Microsoft carbon-neutral data centers, Google's sustainable AI, with the introduction or with the adoption of this technology. That's big offer and really responsiveness from this cloud service provider. They have to keep and they have to stick to their premises. The last one, security enhancement. Advanced security measures, including AI-driven threat detection and strong encryption, protect cloud environment, because the security remains a concern in today's advanced cloud computing services. So that means AI-based threat detection, such as IBM's Watson AI, analyze cloud traffic patterns to detect and prevent any cyber threats in real time. Advanced encryption, end-to-end encryption techniques such as the homomorphic encryption allow data to be processed securely without being decrypted, enhancing privacy. So that means advanced features or advanced technology in ensuring security solutions is also something that guide the future of cloud infrastructure and data centers, meaning still this security and privacy remains a concern. So the summary and conclusion of our lecture video, is that cloud infrastructure enables scalable, cost-efficient computing. This is obviously it is obvious and clear. We have presented it on the previous slides. Data centers have evolved to support modern cloud needs. So this is also the fact that data centers can evolve to support modern cloud needs. That means there is another future advancements or expectations technology to support the modern cloud needs. So still the data centers are evolving. Then efficient cloud management ensures security and optimization. That is what we have seen in the previous lecture. Then future trends will further shape cloud computing and operations. Thank you.